This is Kulali and her owner Garth. Garth was a successful engineer who started building Kulali as his final life project. Unfortunately, Garth never got to see her finished. I've been lucky enough to take the challenge on of completing her build and one day to sail her around the world. Similar to Garth, I'm a passionate engineer who loves to know how things work and how to build things. Join me on this journey to bring Garth's dream to life. This is Sailing Kulali. In this video, we're finally going to put the engine into Kulali. This is a brand new 34-year-old engine called a Saab K4D M4. So for the lift today, there's going to be two lifting points. One is on this side, and which is on the transmission side, and the other is on this front connection here. So to isolate the motor from the aluminium hull, I've 3D printed these feet. They're made from PETG. They're bloody strong, and in compression there should be no issue. So let's see if they'll fit. It turns out that this was a pretty stupid idea because in an engine bay it gets pretty hot and plastic will creep, so I decided to throw these out anyways in future. Tell me directions. Happy there? How is that luck with this height of the fork? Nice, so we'll disconnect and then reconnect it. We had to re-rig the motor a few times because the forklift couldn't get high enough to get over the handrails. So once we got it over the handrails, we had to re-rig it again to be able to lift it up higher to then put it into the boat. Hitting it. So what, we're just going to go down and then we're going to go in a bit more?
Yeah.
We protected the sides of the companionway with cardboard and then used the chain block to slowly lower the motor into the cabin. The cabin. Once we had lowered the motor into the companionway, we then set up a forward line through the middle hatch of the boat, which we could then sling the motor with two lifting points to swing the motor forward. This worked pretty well, and we just had to make sure the angles weren't too shallow, which would have loaded up the lifting gear too much. It was a big relief that this worked because removing the motor, I actually put the jib of the forklift through the window openings, but now the windows are in, we couldn't do that. After only a couple hours, we managed to get the boat motor into the boat with no fingers damaged. Now that the motor is in the boat, the next step was to align the motor to the drive line. The alignment of the engine to the flange is what we're working on now. The first step is to get this flange in line axially. So this flange of the engine in line with this flange. The first step is to get this axis in line with this axis. I've got this stuff called Isoval 11 instead of those 3D printed engine mounts, because the 3D prints I've worked out will probably creep over time and stuff up this whole process. So Isoval is basically just fiberglass sheet, and this doesn't compress and it can last in an engine room. So now with adjusting the legs, the motor is very in line in terms of the flanges, it's very close. Now what I'm doing is I'm using a feeler gauge and going in. This is 1 mil, so it's still quite far off, but 1 mil, and you can see it's loose down the bottom and it's tight up the top. So that means that if it's loose down the bottom, the front of the motor needs to go down to close up that space and open up the top. So I'll loosen the front mounts a bit, and that will change the angle. The other way to do it would be to raise the back as well, but if you raise the back, the engine might come higher on the flange. So it's a balance of keeping this in line and changing the angle. So I'll loosen the front down a bit. Alright, so with a bit of adjustment now, the 1 mil doesn't go in at all, which means it's closer. So now I'll change the feeler gauge to a lower model and then see what happens. So this is a 0.15 feeler gauge. On this side it's loose, the bottom it's tight, loose at the top, right, loose at the top, and then tight on this side. So it doesn't even want to go in on this side. So it's tight here, tight on the bottom, and loose at the top and at the port side. So the motor needs to come up. So this needs to tighten up here, and it needs to tighten up here. Alright, now that the engine is pretty much in the right spot, I'm going to drill these mounts. That will still give a bit of sideways adjustment and up down as well. So that's good. Alright, so the first holes have been drilled for the engine on the Isoval, and so the next step will be to get the right size bolts, do a final check of the flanges for the alignment, and then after that I'm gonna put in this water lock, which is so the exhaust can run properly, and then I'm going to put in the water intake, which will go to a sea strainer, which will go to that intake there. So just to explain, the water lock holds the water that the wet exhaust creates in the lines from the engine out to the exhaust outlet, and so the water lock has to hold the water in the lines, but also the water in the lines has to flow down to the water lock, and there are all these little rules of thumbs to follow, like the minimum distances and the minimum falls. So luckily that's all been sorted and we can move on. Even though I thought the water lock was going to be a relatively easy project, it went pretty far overboard in terms of me overcomplicating it and becoming way too engineering. So I 3D printed a mount, and then I 3D printed a strap, which was a bit silly when you can just buy a rubber strap, but I thought I'd just try out some fun stuff. So after all that clever engineering with this strap and the 3D print to hold it in place and all these clear tolerances, the problem is this flange actually moves back and forth. So it's definitely going to hit that. So now what I need to do is I need to remove all this, cut away to make some clearance to move that across. Anyways, this got way too complicated and I decided that I'm going to scrap it all and I'm just going to weld in an aluminium support and use a rubber strap which is made in the USA, and it turned out way better, but it was a huge battle. After completing the water lock, I moved on to fabricating a flange for the exhaust of the boat. I shimmed the exhaust pipe on the outside of the boat to keep it concentric, and then welded the pipe to the flange. This way it would not move around. It was now time to do a test of the motor to see if we had done the alignment correctly. We did a final torque up of all the bolts and greased up the shaft tube as well as the propeller hub itself. This was pretty exciting to see water flowing through the exhaust for the first time. With the engine now running, it was time to test the hydraulic output shaft, which laterally or axially moves the shaft to feather the propeller. I was pretty scared about clashing the propeller and destroying it.
Moving all right? Yeah, I'm going to move it more.
Fortunately, I got the measurements right and the shaft moved as expected.
So that's full reverse. Yep. Full forward. Perfect. Awesome. That's perfect. Looking pretty good.
With the feathering test successfully completed, it was now time to engage the drive and rotate the propeller. To everyone's surprise, when we engaged the propeller, there was no extra vibration, meaning that our alignment was looking pretty good. We increased the throttle to see if any vibration would come in, and again, to our surprise, there wasn't. We also did a test of the propeller engaged whilst moving the pitch in and out to check for any vibration. And just like that, the testing was all over and we had a CBC Pale Ale to celebrate. See ya on the next one.